Okay, we're going to work this problem that's similar to example 3.16 in the book on page 113, using chemical formulas as conversion factors. So what we want to do is we want to find the number of grams of atomic carbon that's in 7.25 gallons of CH3, CH2OH. That's the question that we are asked to solve for. So essentially what we want to do is we want to go from gallons of CH3, CH2OH to liters of CH3, CH2OH. From there we want to go to milliliters of CH3, CH2OH. And from there we want to go to grams of CH3, CH2OH. And from there we want to go to moles of CH3, CH2OH. And from there we want to go to moles of atomic carbon. And from there we want to go to grams of atomic carbon. Now, this step that allows us to go from a volume to a mass, we use the density. From this step, from moles of CH3, CH2OH to moles of C, we use the chemical formula that says they're 1 mole of CH3, CH2OH per 2 moles of carbon. That lets us go to that step. And these other steps from grams to moles, you're already or should be familiar with. So let's start out with this calculation. We start with 7.25 gallons CH3, CH2OH. And what I'm going to do is, that's quite long, so I'm just going to write ET for ethanol. So when I write ET, that means CH3, CH2OH. Okay, so let's start out with 7.25 gallons of ET. And the conversion factor from gallons to liter is, for every 1 gallon, we have 3.785 liters. So now I am in liters of ethanol, liters of CH3, CH2OH. the next thing I want to do is go to milliliters. So in 1 milliliter, I have 10 to the minus 3 liters. Now, this puts me in a unit of milliliters of ethanol. I am in the unit of milliliters of ethanol. So at this point, I can now use my density to get the mass of ethanol. I can use my density to get the mass of ethanol. So now my density tells me for every 1 milliliter, the intensive property, I have 0.785 grams. Okay, so milliliters and milliliters cancel, and this would be grams of ethanol. I'll cancel that from there and move it here. So now we have a mass of ethanol. So from our mass, we need to go to moles. So 1 mole of ethanol, which is CH3CH2OH, gives me 46.1 grams of ethanol. So my grams of ethanol cancel, leaving me with moles of ethanol. So at this point is where we are right now. We need to use our chemical formula to convert moles of ethanol to atomic moles of carbon. So 1 mole of ethanol is equal to 46.1 grams of ethanol. Oops. My correction. That's 1 mole of ethanol equals 2 moles of carbon. And that came directly from the chemical formula. This ratio of 1 mole of CH3CH2OH to 2 moles of carbon. And now I can use the atomic mass of carbon. 1 mole of carbon is 12.01 grams of carbon. So moles of carbon and moles of carbon cancel. And what I'm left with when I do all of this multiplication across the top and then divide, if that's the way you want to think about it, I'm left with 1.43 times 10 to the 4th grams of carbon. So the quantities that we use the fact that 1 gallon is equal to 3.785 liters. We use the fact that 1 milliliter is equal to 10 to the minus 3 liters. We use the fact that 1 mole of CH3CH2OH, which I have abbreviated as ethanol, is equal to 46.1 grams of CH3CH2OH, which I have abbreviated as ethanol. And we have also used the density that says that there are 0.785 grams per 1 milliliter of this liquid. And we've also used the fact that our chemical formula states that for every 1 mole of CH3, CH2OH gives us 2 moles of carbon. And I abbreviated that and said that 1 mole of ET gives us 2 moles of C. So try to work the problem in the handout and go through this video and try to see if you can come up with the correct answer. If you have any questions or problems, you can send me an email or ask me in class.